There is one line people add to a dev container that quietly hands an attacker root on their laptop. One line. It feels harmless. It's in half the tutorials online. I'm going to show you the line, why it's a trap, and what I do instead. But first, the thing that makes your dev container setup reusable across every project you touch. Last episode, I showed you my actual setup, the firewall, the secrets of disk, the whole thing, built by hand. And it worked. But built by hand has a problem. The moment you have a second project, you copy that .dev container folder, then a third. 6 months later, you've got 3 versions of the same firewall script and no idea which one is current. I lived that. It's miserable. So I did the obvious thing. I tore the setup apart into reusable pieces, the firewall, the secrets, the AI tools, the cloud tooling, and packaged each one as a dev container feature. And now I'm open sourcing all of them. By the end of this video, you'll be able to drop this entire security setup into any project of your own in about 3 steps, plus one bit of wiring I'll show you at the end. Repo and credits are in the description. Let's get into it. So, what's a dev container feature? Strip away the buzzwords, and it's a version bundle of installation code and metadata applied when your dev container is built. The important part isn't what it is, it's what you stop doing. You stop copying scripts between projects. Instead, you reference a feature by a published address. Like this. These 2 lines pull in my core and firewall features from a registry. No copied implementation scripts, no drift. One source of truth, and every project points at it. They are published as images to GitHub Container Registry, same place your Docker images live. So they are versioned and you can pin them. 1 folder per feature, 1 test per feature. That's the whole convention. So referencing instead of copying solves the drift problem, but it opens a new one. If every feature is a separate, independent thing, how do they work together? How does the firewall know what the 1Password feature needs? That took me a few tries to get right. Everything stands on one feature called core. Baseline packages, helper scripts, shell setup, SSH config. Every other feature expects it and declares that it must be installed afterwards. So once you include core, the order sorts itself out. Now, there is a decision I want to be honest about, because I got it wrong the first time. My first version had my features hard depend on other people's features, wiring myself to a specific one. Less code to maintain, I thought. Mistake. When you depend on another feature, you inherit it. Unmaintained, or it changes its install method, or breaks on new Ubuntu, and yours breaks with it, for a reason that was never yours. So I reversed it. Every feature here installs the tools it owns directly. If the tool needs another runtime or command, the feature expects that capability to be present, but leaves how it gets there up to you. And this is a distinction that matters. Needing a tool isn't depending on the feature. Firebase wants Java for its emulators, but it doesn't pin a specific Java feature. It just asks for Java on your path and leaves the how to you. That's a rule. Depend on capability, not a particular feature. So every feature here stands on its own, which lands us right back on the question I left you with. If they are all independent, how do they ever work together? Through shared conventions, never by talking to each other. A feature that needs network access drops a file listing its domains into a shared folder. The firewall doesn't know those features exist. On startup, it reads every file in this folder and allow lists what it finds. 1Password declares what it needs, the firewall enforces it, and the 2 never touch. Same shape everywhere else. Needs a shell variable, like BuildKit's pointer to its builder, drop a script into a different shared folder, and core picks it up. For startup hooks, each feature contributes its piece and dev containers combines them, decoupled but cooperating. Which brings me to one feature that cooperates by deliberately refusing to do the obvious thing, and it's the one protecting you from that line I mentioned at the very start. We'll get there, but first, quick tour of the whole lineup. Think of it as a menu, not a manual. First, core, the one every other feature needs. Then firewall, the allow list rules, DNS capture, the domain tooling. It even ships a small VS Code extension that makes a firewall something you can actually see, not just trust. More on that when we boot the container. That's a security spine from the last episode. Now just a feature you switch on. Secrets, the one password feature, the CLI and the service account flow I walked through in the last episode, packaged into one line. The AI assistants, Claude, Codex, and a choice between Gemini and Gravity. Pick one, they are mutually exclusive, and the setup will actually stop you if you enable both. And the cloud and infrastructure tools, gcloud, the Kubernetes bundle, Firebase. Mix and match. A small project takes 3 features, a cloud project takes 6. Same spine underneath. And then there is a BuildKit. This is the one. If you've ever wanted to build a Docker image inside a container, the internet tells you to mount the Docker socket. This line. But that socket isn't a build tool. It's a control plane for Docker on your whole host. Code on your container can use it to start another container, mount your home folder into that one, read every other container and volume on the machine. It steps straight through the boundary this whole setup exists to build. And don't reach for the just use the official feature as a fix. Docker outside of Docker, Microsoft's own, does the exact same bind mount. Different target path, same host socket underneath. So I don't mount it. Instead, only the BuildKit client lives in the dev container. The builder runs as a separate, rootless container besides it, started from the host before your dev container even exists. They share a network, so the client can submit builds, but neither one can touch the Docker socket. One honest caveat. This isn't a second firewall. The builder still pulls and pushes over the network, and malicious code could submit its own build down that same path. What it can't do is the most dangerous part. It can't ask Docker for a privileged container, can't mount folders off my laptop, can't see every other container on the host. No socket, no host mount, rootless. Nothing can go wrong, just a much smaller blast radius. Build capability without control of the host. That's the menu. Now let me show you how little it takes to use it. I shipped the working starter right here in examples. I will reuse the repository from the previous video and recreate the matching setup. Now the steps. Step 1. Copy this folder into your projects.dev container. Step 2. Keep the features you actually want, delete the rest. Core stays always. One more thing while we are here. The image line. Any apt-based image works. This one uses my published base, Node 24, with a handful of common tools baked in, so the layer cache warms fast. Swap it for whatever image you already use. Step 3. 2 files to fill in. Host.env gets your password account, the path to your token, and your BuildKit settings. And allowed domainsconf gets the domains this project actually needs. Your Git host, your registry, whatever this repo reaches out to. The stuff that's specific to you lives in these 2 files, so everything else stays copy-paste clean. There is one more file in here, and it's the one piece I genuinely can't hand you as a feature. A feature installs inside the container, but some of this work has to happen outside, on the host, before the container even exists. One password fetches your token. BuildKit starts a separate builder besides your container. And code inside a container can't reach out and start a container next to it. So every feature that needs host-side setup ships a little host script in the repo. And this hook, it just downloads each one and runs it, right before the build. Nothing to copy, nothing to keep in sync. Pin the feature references and you know exactly what's about to run on your machine. This is the one bit of wiring you connect by hand. Everything else is the features doing their thing. And it trims the same way the feature list does. Drop a feature from devcontainer.json, drop its version variable here too. One feature, one line. Keep them in sync and there is nothing else to think about. And that's it. Reopen the container, the secret resolves, the builder connects, and the firewall comes up with the thing I told you to watch for. There, that's the extension I teased. It shows you the live allow list, the attempted and ignored domains, and toasts you the instant something new gets let through, like just now. That's a firewall you can see instead of just trust. And not one line of any of this was a script I hand wrote into this project. It all came from the features. One tip before you do this for real. Pin every reference, feature versions, the base image, and the whole script commit. Then your setup stays frozen until you choose to update it. That's the entire reason this beats copy-paste. Copies drift, references don't. That's the whole setup. The repo and the example setup are in the description. Clone it, pick your features, make it yours. And tell me, what tool do you wish was in here? Drop it in the comments. If a few people want the same one, I'll build it and add it to the collection. And if there is one already in here you are not sold on yet, the feature you'd skip, I want to hear that too. See you in the next one.